Okay, today we're going to compare sets of data. And so understand that basically we're talking about a linear transformation if you add something to a data set or if you multiply something to the data set. So in this case, when you add something to the data set, you can see that the ranges do not change. So notice that each value was translated 5 units to the right. Thus, the mean, median, and mode increases by 5. Since the new minimum and maximum values also increase by 5, the range remains the same. The standard deviation is also unchanged because the amount of which each value deviates from the mean also, stays the same. So in transformations on addition, when you're dealing with data sets, in conclusion, the mean, median, and mode of the data sets can be found by adding the k value to each of the mean, median, and modes, and the range and standard deviation will not change. So I'm going to do a couple examples, and I'm going to pause it and to get ready. Okay, so if I put in this first example all of these numbers in list 1, so I did stat enter. In list 1, I put all the values. So what I want to do now in list 2 is I want to add 7 to all those values in list 1. So I go up to list 2 and I say list 1 right there, list 1 plus 7, and that gives me list 2. Now I can compare the data sets, the mean, median, mode, range, etc. So the way you do that is go into an open window, second quit, hit stat, calculate, variety of stats, enter, and list 1, second 1, which is list 1, and hit calculate. And that will give me the variety of stats. So the mean is 9, the standard deviation is 3.3, which it says over here to the right. And then if I want to find the 5-number summary, I arrow down, there's my median. My mode is 8 from the list. 8 is the most frequent, and range is 14 minus 4, or 10. So you can compare that with list 2. List 2, I go second quit. I go stat, calculate again, variety of stats. I change list 1 to list 2, so second list 2, and I calculate that one. And there's your mean, which is right there. And I can go down to the 5-number summary. Here's your standard deviation. Remember the sigma. The standard deviation 3.3. I go down to the 5-number summary. There's my median. My mode you find most frequent in list 2. And my range is 21 minus 11, or 10. Now this example here talks about Tom's earnings if you multiply by 10% his earnings to see what would change. So really you're multiplying by 1.10 each of the values. And what happens to that is when you multiply by a data set by something, the mean, median, mode increases by that factor of 10%, 1.10. Some values were increased by a constant percent and not by a constant amount. The range and standard deviation both changed, also increasing by a factor of 1.10. So you can see that in the data here. Standard deviation, here's the mean, 48.6 goes up to 53.5, which is 10%. 4.9 goes up 10% for that standard deviation. Since the medians of both bonuses are equal, and the means are approximately equal, whoops, I'm going to slide that down. It says that Tom should ask for the bonus that he thinks he has the best chance of receiving. Okay, that's what that data set would mean. Now I want to do the next example. All right, on this example we have, we're just comparing the means, median, modes, range, standard deviation if we multiply a set by 3. So the way you do that is in stat, enter, put in list 1, all of these numbers, that's list 1. Now list 2 is going to be list 1 times 3. So I go up to the top of list 2, I type in second list 1, because it's second 1, L1's in blue, times 3, hit enter, and I just multiplied everything by 3. So if I find the mean, median, mode using stat, calculate, variety of stats, okay, list 1, go down to calculate, I'm going to get these values. Mean of 16, a median in a minute. I'll show you the range. So 5-number summary, the standard deviation 3.7, as you can see over here, 3.7. I go walk down to the 5-number summary. Here's your median, 16.5, and your range is 22 minus 10 or 12 right there. So if I go second quit, get out, stat, calculate, variety of stats, list 2, stat, let me do it again, stat, calculate, variety of stats, second, list 2 in blue, go down to calculate, hit enter, and now my mean is 48, and my standard deviation moves to 11, which is the sigma sign, and you can see max minus the min, 66 minus 30 is your range. And that's how you compare or get your stats. Okay, these next two examples I'm not going to do on the calculator because I have just done that. But the reason why you want to put these in list 1 and list 2 is because there's so many points. So that's why you do that, so you can easily come up with a histogram or a box and whiskers plot down at the bottom or whatever. But you use the mean and the standard deviation to compare two symmetric distributions, which these two are. If you were to put these are Robert's quiz scores and Elaine's quiz scores. You use the 5-number summaries to compare two skewed distribution or a symmetric distribution and a skewed distribution. That's what you use the 5-number summary for. So that's what I'm talking about when you do both of these. And then if you want to do the variety of stats, if we were to do that same thing on our graphing calculator with Robert's and Elaine's scores, then we could do that, and you would get this right here. Your mean would be 84.7 and 84 here. Standard deviation 7.5. Standard deviation of her scores was 4.6, which means that Elaine's quiz scores are generally closer to her average than Robert's scores because the standard deviation is lower, as you can see, 4.6 to 7.5. Now, if you're looking at box and whiskers plots over here to the right, this is Kurt's rushing yards his junior and senior year. How many yards he got his junior year, how many yards his senior year. And if you see the box plots here, you can compare them and see that his junior year is a lot less than his senior years, and his senior year is more symmetric. So if I was to do box plots on this with the two examples I had, I turn on the box plot, and if I hit graph, you can see that my box plot's not there because my window's not set up. So I'm not going to do it right now because I'd have to put all these in, and then I would get the same thing. But you could do this. You could do this going stat, calculate. You could go up, clear this, go up to the top. You always go to the top, clear, and enter to clear the list. Put list 1 in, list 2 in, and then you can make the box plots by going second stat plot, turning them on, and going to a box plot. And you could put them both in list 1 right here. And then if you did list 2, you'd go second stat plot down to list plot 2. You'd put list 2 here. So you could put these two lists in and make these two box plots right here for Kurt's junior and senior year. All right, good luck on distributions. You're really explaining what's happening to this, okay?